Hey everybody, welcome to my talk on Cypress, titled Automated Testing All the Things with Cypress. My name is Jordan Powell. I'm excited to not only give this talk, but also answer any questions you might have after the talk here in the chat as well. Let's see here. Okay, so first question to ask is, and the first thing is we want to start here is because why do we need testing? Because everything I'm about to share, if you don't believe in the power of testing and what it can do for yourself and for your team, all these things are sort of useless for very impractical for you. So I wanted to share for those of you who may not be testing or only doing certain parts of testing. I guess why testing can be a valuable, something valuable to lean on as you begin to continue to work on your applications, create new features, fix bugs, those sorts of things. Because at the end of the day, our time as developers and really as humans is the most valuable resource we have. Everything we do in life, we exchange time for it, and so when we write tests, we want to make sure that the time we spend to write them, that we have a positive ROI on the other side. Because if not, we're wasting our most valuable asset. So the first thing I think to hammer away at is that testing provides really, it's sort of like automatic documentation. So as you begin to write tests, you are actually in a lot of ways documenting the behaviors of your application. I know, like, as you begin working, if you work on a large scale like enterprise application or something like that, where you work on certain parts of an application with a large team, or even if it's just a project that you're tackling by yourself, that maybe you're spending months or years on, eventually you sort to lose scope of the certain parts of the application. And testing provides a great documentation so that you can go back and say, given this, this is what's expected. And I know, like, for me, there will be parts of my apps that I'll be like, I have a good name. I'll be like, do this thing. But sometimes I'll ask, like, why am I doing this? And then if I go to my, my unit test or my intent test or something like that, then I'll be able to read, given, this property pass into it, we're expecting this behavior to come out the other end, or whatever the instance is. Testing really provides documentation that I think that from a developer and from an analyst standpoint, I think certainly can provide value. I don't think it's the reason why you write tests, but I think it definitely is a positive part of that ROI we were talking about. One of the things that I think that I feel like is maybe one of the strongest candidates is that it provides you confidence. So as a developer, you begin to write code, and obviously the more code you write, the more confident you get that what you're writing works, right? The more you implement, once you start implementing TDD, and the more you actually implement a TDD or test-driven development approach to development, you'll notice that I've heard it said where when you first start off as a developer, you write code and don't know why it works, but then the more seasoned you get as a developer, you write code and you're like, I wonder why it's not failing. Like, you begin to switch your perspective. And I think that where TDD helps change that game is you write a test, it begins to fail, and then you begin to you write code that implements the requirements that you had already wrote in your tests, and you write them until they pass. And the more you begin that cycle, those passing tests they really become confidence for you as a developer, confidence for you, for your team, confidence for maybe your QA team. Really just confidence knowing that whether it be the code that I write or someone else on my team wrote, if it's passing the tests, then there's a much smaller likelihood that it broke something else in my application. So obviously confidence is a very important part of that equation. Obviously, another one is safe refactoring. So refactoring is an inevitable part of development. Requirements change. You may be part of an instance where you over engineer something or you under engineer something, and you say, let me refactor this, so I add an abstraction or maybe I remove an abstraction. Whatever instance you find yourself in. I've never been on any size project of substance where refactoring wasn't definitely a part of writing the application. And with tests in place, you can safely refactor your code, knowing that as you begin to refactor and pull and move parts of your application elsewhere, your tests are going to fail. But once you get them all in place again, they will all pass again. And so just knowing, and it sort of leans into that confidence of you have the documentation in place, you have the confidence that the features that you wrote previously work. Now when you refactor, you now know when you got the parts back in place again. And then finally, an improved UI. So some of the things that we'll begin to show you here later on in the talk is some of the ability with Cypress to, like an end-to-end scenario, test the differences between browsers. So with testing, you can get an improved UI, or in some ways even just more confidence knowing that this button you added, or this animation you created, or whatever your scenario is, that it not only looks right on the screen every single time, but it also looks the same way from one browser to the next. Certainly an important part of the development. So here is something I would like to share with you. So a lot of you are probably familiar with, there's different names for it, but I just call it the testing triangle. And essentially here we have a pyramid that sort of represents, I guess, the scope of automated testing. So in the bottom we have unit tests, which are really the most common form of testing. And if you're not doing any testing, it's definitely the first place I would recommend you start testing. And they are the perfect place to start because you are really just testing one individual part of your application. Typically it's going to be, one class or one function or one method on a class. Basically, how does that one unit or that one piece of code you're writing, does it actually do its individual responsibility as expected? Unit tests are going to be small. They're going to be very cheap to write. They're going to be very quick to run. So ultimately, that's going to lead to a high volume. So your application is going to have a lot of unit tests, because not only are they're obviously very valuable because they provide the confidence that the parts you're building work, but they're also going to be really fast to write and fast to actually run them themselves. On the top end of the spectrum, you have end-to-end tests, which are going to not just test one individual unit, but it's going to test all of the units of a subset feature or behavior of your application from one end to the other, hence end to end. And it wants to make sure that given the user, creates a blog post and then types in here and does this and then deletes this and then saves and then reroutes here, like it will actually test the full end to end more like a manual test to make sure that, as you begin to build your applications, that from end to end, everything works as expected. Obviously, at the top of this triangle, it's much smaller than at the bottom. And so part of that is for multiple reasons. One is that you're going to have a lot less end-to-end tests because mostly because one, they're going to be more difficult to write, so they're going to cost you more, and they're going to be slower to write, or slower to run. So because they're more expensive to write and because they're slower to run, you aren't going to write as many of them, and ultimately you will want to use unit tests and integration tests to leverage other things and just use end-to-end tests to test specific scenarios that are hard to test otherwise. So I think these separations can be confusing at first, but I think that the more you get into it, just start with a unit test, and then when you have multiple units that communicate and interact with another, that's where you get integration tests, where one unit connects with another unit. So one component interacts with another service, or one component interacts with another component, or this service calls this other service, or so on and so forth. So integrating two parts together, testing how that integration connects, that it works every single time, the exact same way every time. That's an integration test. It's sort of it's more than a unit test, less than end-to-end test. So it's going to be more difficult to write, a little bit slower to run than a unit, but less than end-to-end. So you sort of have this sort of increased level of complexity and expense for every step of this pyramid. The other thing to think of is a rule of thumb to consider is that with these tests, it's like the factor of 10 is what I like to call it. So you're going to have, say in an application, you're going to have thousands of unit tests. You may have 1,000 or 10,000, or you're going to have several thousand typically on an enterprise application. With that being said, you'll probably only have hundreds of integration tests because there's a lot more units in an application than there are integration between those units. And if you have thousands of unit tests and hundreds of integration tests, you may have only tens or dozens of end-to-end tests. Just to, again, keep in mind for those who aren't familiar with sort of what type of tests run what, that's sort of some general guidelines. And if you aren't doing any end-to-end tests or integration or unit tests, certainly love to help answer any questions you might have after this talk. So here's I love these GIFs. I see them all over the internet. They're super funny. But it just shows the door and then the swinging arm, those things could be independently unit tests. Those units work as expected, but when they're put in correlation, in connection, when they actually integrate with another unit of the, in this instance, the system or your application, they begin to definitely not act and behave the way you intended them to do. So it's just a funny way of showing the need for more than just unit testing. So let's get started with Cypress more specifically. So Cypress, for those of you who don't know, it's a next generation front-end testing tool built for the modern web. It addresses some of the key pain points that developers and QA engineers face when testing modern applications. Cypress in particular, it can write end-to-end tests, integration tests, and unit tests, so it can test all the different types on that testing pyramid. But Cypress really focuses and provides a complete end-to-end testing experience. So Cypress can test anything that essentially runs in a browser, but its real focus and bread and butter is providing you with an easy, quick end-to-end experience. So it knows that there are other other testing tools out there that run, like Jest and Karma, and that do end-to-end tests or unit testing and integration tests and other things well, whereas end-to-end tests have primarily been very not fun to write, and so that's where Cypress really comes to the rescue. So I guess why Cypress? Like, what makes Cypress different than other applications? So number one is that it does not use Selenium. So most end-to-end testing tools are Selenium based, which means they essentially share the same problems. Cypress is different because it's built on a new architecture, whereas a lot of the other ones were built on Selenium, and essentially Selenium executes commands actually through the network, where Cypress runs in the same run loop as your application itself. So Cypress is like a wrapper around the actual browser instead of trying to sort of execute commands through the network. Cypress actually it wraps your application, and therefore it has access to really the entire scope of the browser itself. We'll get into more specifics of that. Cypress focuses, like I just mentioned, on doing end-to-end testing really well. So it's not a general automation framework, nor is it a unit testing framework for your backend services. Though there are, like I mentioned, there are other great tools that do that, but instead Cypress really focuses on making and writing end-to-end tests for your web application really as simple as possible. Cypress works on any front-end website or framework. You can test anything that essentially would run in a web browser. All the architecture surrounding Cypress is built to handle any modern JavaScript framework, as well as any in the old like server rendered pages or applications, but certainly whether it's vanilla JavaScript, React, Angular, Vue, Elm, etc. It will do an amazing job at testing them. Cypress itself is only written in JavaScript, so while you can compile down to JavaScript from any other language, ultimately the test code of Cypress is executed inside of the browser itself, and therefore there are no like driver bindings, and basically it just makes it a little bit more simple, and they have also really like made that promise that JavaScript is and will always only be what is used for doing that. Cypress is an all-in-one tool. So typically in the past, in particular, writing end-to-end tests would take a lot of different tools working together. Well, with Cypress out of the box, you really get bootstrapped multiple tools in one subset. So there's no need to install, a dozen separate tools and libraries to get your test suite set up. Cypress took that time to basically wrap all those things into one library to provide really best-in-class tools that you are already familiar with and able to use, and they really just work together seamlessly. Cypress is a great tool for both developers and QA engineers. So this is one of my favorite things is that it's not just for developers or just for QA engineers. I feel like it makes it work for both people in a pretty easy way. So I think that that's always nice when you can kind of have some cohesion and buy-in from both of those units on your teams. The other major thing, obviously, for people who have ran or run end-to-end tests before, they could be very slow. Cypress runs much faster than the tools that you have maybe previously used. The architectural, because of the architectural improvements that are built with Cypress, it really unlocks one of the greatest things of Cypress is the ability to do TDD with end-to-end, which hasn't really ever been possible before. Cypress was built so that testing and development can happen simultaneously. You can develop faster while driving the entire dev process with tests, because you can see your application. You can still have access to the developer tools. Changes are reflected in real time. The end results is that you have developed more with and that your code will be better and that will be completely tested. So you can actually end-to-end do TDD, which we do a lot of unit test TDD, but not really end-to-end testing TDD. So you get a new if you're on a sprint team, if you get a user story, you could literally test out that user story. A user clicks this button and then this happens and this happens, and then at the end we're expecting this. You can actually write a unit or an end-to-end test in Cypress and then TDD the process until you see that passing in real time, which is really cool. So here are some just high-level features that Cypress, I think, really does well at and kind of sets itself apart from other frameworks. So Cypress takes snapshots as your test runs. So simply you just hover over the commands in the command log, and you'll see exactly what happened at each step of the process. So if any of you have used a tool like Redux before, and you have the Redux dev tools where you can time travel every action that was dispatched into your reducer, you get that same sort of behavior with Cypress, because you get the time traveling where you can see every step of the test. You can go back and see a snapshot of what the DOM looked like in that. So I think that's a very cool feature. You get real-time reload. So every time you make a change to a test in Cypress, it will automatically reload the app in Cypress. Here's another thing I think that's very underrated part of our feature of Cypress is the debuggability of it. You get very readable errors, which depending upon other frameworks you're coming from, very difficult to read some errors from some of these frameworks. But with Cypress, they're much easier to read, and you get that debugging directly in the Chrome DevTools. So because Cypress is built around, it really wraps the browser itself. You just literally open your Chrome DevTools or your Edge DevTools, and you have that debuggability to see network requests, console errors, all those things directly inside Cypress. Automatic waiting. So this is one of the big pain points with Selenium-based applications, is that you had to add a lot of waits for your commands, because there would be sort of like race conditions where you're waiting for this request to come back, or you're waiting for this animation to appear on the screen, or just the way the DOM would interact with other parts of the DOM. You would have to add these waits so that you wouldn't have this issue where you're waiting for one part and then it would fail because it needed another 300 milliseconds for that thing to actually appear on the DOM. Well, Cypress automatically waits for commands and assertions before it moves on, which is very, very nice to not have to do that. You have the ability to add those in, and we'll see it here with SPI, stubs, and clocks. So you can really control the behavior of your application. So whether it be a Lambda function from a cloud server, or a server response, or some type of timer, it really gives you like the same functionality that you love when you write unit tests in your fingertips for end-to-end testing. You get network traffic control, so you can easily control, stub, and test edge cases without even involving your servers. So you can stub network traffic however you like. and we'll get into some more examples of that, but some really cool things with that. Constant reliability. So I mentioned before with waiting and all the different parts that were really a headache with Selenium or WebDriver, you just get much more consistent, faster, reliable, and flake-free tests, which definitely, there's nothing worse than you merge your feature or a bug fix into your brand, into master or production, or however your process is set up, and you run it and you get some flaky end-to-end test that fails, and you rerun it and then it passes. So those are certainly frustrating things that you really don't get with Cypress. You get screenshots and videos, so you can view screenshots taken automatically on failure of your videos for your entire test suite when you run them headlessly. So you can see screenshots of any failures that happen, and you get the entire video recording of the entire suite built in out of the box, which is just super cool. Built for scale. So Cypress has multiple ways to not the platform itself is built for scale, but they also have a dashboard product. So Cypress is a free open source tool, but they do provide additional pricing options for enterprise applications that really need to scale. Certainly you can contact them to get some of those pricings, but for the most part, you really don't need any of the paid things because Cypress it's used by over 11,000 organizations. It's used in over 15,000 projects. It has over 500,000 test run hours, and over 300 million tests have been recorded on their dashboard program. So with Cypress, with its dashboard, you can actually run parallelization. So if you have a test runner that takes, say, an hour to run, but if you parallelize that between, say, 4 servers, well, it'll only take 15 minutes then. So there's some really cool additional scalability options that it provides for your application if that's something you're interested in. One of the other amazing things that came to pass this last year, I think it was with 3.8, but Cypress has the ability to run tests across multiple browsers. Obviously, we have because Cypress is wrapped around the browser itself, so we have because Edge and all these other applications use Chromium now. We have support for Cypress with Chrome, Firefox, Edge, Electron, Brave, and more. I'm sure there are others, and more I'm sure will be coming as well. So awesome to see that. How you do that is when you open up Cypress, you actually see here, you can actually specify the actual browser you want to run it in, and it will run the test, literally open up that browser with your test scenarios, and it will run it. The other option is you can run it headlessly just by specifying using the browser flag and the name of the browser, or you can create a script in your package.json and set those browser flags as well. So here is what it looks like. Just to install Cypress, it's really simple. npm install it. It will then download Cypress. It will unzip it, finish the installation. You then just have to run open inside Cypress, and it opens up this Cypress test runner. You can then pick a single spec or run the entire spec, and it then opens up the Cypress the test runner, and it runs through every scenario that you wrote. Is pretty cool. So how does it specifically work? So I'll try to run through this quickly, but it basically works by leveraging jQuery. So we finally, after all these years of using jQuery for, in a lot of ways, really the wrong tool for the for the job. It really, in my opinion, is like the perfect use case for jQuery, where you get to use jQuery's powerful selector engine to make to select parts of your application in the DOM. Excuse me. And because it uses jQuery, for anyone who's done any type of front-end JavaScript development, the tests are going to be very familiar and readable for pretty much most modern web developers. So the way it works is Cypress uses subject management, and it uses promises. So you always create a new Cypress chain with the side command. So cy dot and then a command, where what is yielded by the command, it establishes what the other commands can be called next. So you'll have some methods such as cy.get or cy.contains. It will yield a DOM element from the DOM, and it will then allow further commands to be chained onto them, like a click or a clear or type or something like that. One thing to remember is that Cypress commands do not return those subjects. So when you do cy.get and then instance here on line 1, input.post title, it doesn't return the input with the class of post title. It just yields that subject. Cypress commands are asynchronous and get queued from execution at later times. And so during the execution, those subjects are yielded from one command to the next. And a lot of helpful Cypress code runs between each command to ensure everything is in the correct order. And so with that in mind as well, because Cypress is using these commands and it uses promises, you can then just do .then to that subject to tap into that command chain. So pretty cool as well. So that being said, we have these chains of commands. So to get more specific, it's very important to understand this mechanism because Cypress chains commands together. It manages a promise chain on your behalf, with each command yielding a subject to the next command until the chain ends or an error is encountered. So as a developer, you don't have to know everything about promises, but obviously some understanding of it works. So basically you establish some element on a DOM typically and create that as a subject, and then you interact with those subjects by chained on actions on top or onto that command, and it will continue passing through that chain until an assertion is made or an error is found. So here are ways you can interact with those subjects. So once a subject is established, so for an example like cy.get an input, you could then interact with that element by using .type or .blur, .focus, .clear. You could check or uncheck a box. You could select it, double click, right click, so on and so forth. And obviously assertions are an important part of any test to make sure that you're asserting that the element is visible or has a particular attribute, CSS class, state, etc. So basically assertions, in this case, you're just going to assert that the desired state of your application is what you expect it to be. So here, let's see what it actually looks like. So like any other test, you're going to create a describe command, which will sort of describe what this end-to-end scenario or group of tasks will do. Excuse me. So we describe, in this instance, we're talking about posting resource. So we use an it statement to describe an instance of this, where we're going to create a new post. So in order to create a new post, the end-to-end scenario is we're going to use the side command to visit. So we're creating a subject of visit, which basically it routes the URL to /post.new. cy.get creates, we're doing this twice here, where we're getting a subject, two inputs. An input with a title of post, or a class of post title and a class of post body. So those two subjects then get interacted with by the type action, where you literally type. Well, you'll see the the test runner type in that control my first post and hello world. So you can see us creating a subject and then making or acting upon that subject. We're also using the cy.contains, which is a way of finding an element, creating a subject by finding an element in the DOM that contains that text submit. And then we're acting on that by clicking. So in this instance, we're finding a button that says submit, and then we're going to click that button. Creating another subject by using cy.url, and in this instance, we're then asserting that subject that says we want to assert that the URL will include posts / my first post. So we want to make sure that after we click this button, the URL at some point in it includes that string of text. And then we want to make another assertion by creating a subject of cy.get and h1 tag that should contain the string my first post. So that's an example of how you can create subjects, act on those subjects down the chain, and then make assertions on what happens next. So here, this also is sort of this will look like when you open up Cypress, the files and what is found inside of your code editor. You'll see everything will be wrapped in a Cypress folder. And then it will have fixtures, which fixtures are used as external pieces of static data that can be used by your tests. These files are located, like I said, in the Cypress / fixtures by default, and you can change those obviously. And then your actual tests will run by default in the integration folder. You can then group them by groupings of of tests, and then specific spec files that actually run those tests will be found there. There are also additional plugin and support files, which are sort of just helper convenience mechanisms, so you don't have to import something like a file into every single one of your specs, because they can run before every one of your specs run. So let's look at some examples. So I have, let's see here. So I created I have an app. It's just it's a really silly app. It's just a Chuck Norris joke app. So I'm currently just serving this app as an Angular app. So if I do ng serve, you'll see if you can see it. I move myself. You'll see we're running this. And then if we do, to run Cypress, we just do mpx Cypress open. This will actually open the Cypress test runner, and you'll see from there. So we then have these Cypress folders up here. Let's see. Oops. Not sure if you can see this or not. So you can see here we have the Cypress folder with a fixture and 2 integration files. Pretty simple. Also created this helper command as well, which we can get into briefly. But here we see we ran the application. It's running, and we are running the Cypress app, and you can see it's pulling up here. And so all we have to do is we can run one of these tests individually by just clicking on it. It will then open the application up. And you can see in this instance, this application just literally loads 4 jokes from a Chuck Norris joke API. Something, if you want to see, we actually have you want to actually, so the actual application itself will run, it will look just like that. So if you just go to localhost 4200, it literally creates this, loads these jokes, and you can refresh them and it loads new apps, new jokes. Pretty simple. It's a pretty trivial example, but it's an example. So here we ran one test, but if we go back to here to our Cypress runner, we can also stop this and we can run all the specs. And we can also see here, we can pick our different browsers we want to use. But if we click run all the specs, it will actually click through and run all the spec tests that we have. So in this instance, this end-to-end scenario, we are literally making an API call to the API and returning them. So you'll actually get, every time you run this, you'll get 3 different random jokes. We also have a stubbed instance where it's returning the same exact test every single time because we are stubbing this data. Because there's going to be instances where you don't want to hit, say this is a more complex app and we had all these instances of things we wanted to test. Well, we don't want to hit our API 500 times. You can stub those results pretty easily, and I'll show you how to do that. So here we have, I'll show you how this is done. So we have, here's the API call. And so you'll see here, hopefully we can zoom this in a little bit. Let me move this down a little bit. So you'll see here, we have, we're describing this, the Chuck Norris API. Before each, we're visiting this URL, and we want to make sure cy.loader, which is coming from, I created this command because this loader turns on and off every time it's loading new things, and I didn't want to continue doing cy.contains this thing. So all I have to do is cy.loader anywhere in my tests, and then I can run assertions against that. So this is just a helper thing that you can easily test. So before each test, I want to make sure this loader exists, it's on, and after each test, it should not exist. So this is just a easy way you can, without making these tests super verbose and long, you can test these things. So in this instance, we're making a request to this API. It's actually going to get the request, make a request, it's going to come back. We're going to expect the response status to equal 200. We're going to make sure that we have 3 jokes and with 3 images. So this is a way where we're testing what's on the DOM. We're testing the results from the response from this. So you get with Cypress an easy way where you can actually make end-to-end tests. You can test the responses, and it becomes very verbose in what you can do. But here is an example of, so I created a fixture called jokes.json, which essentially we are going to, as we would begin to create more and more tests for this application, we wouldn't want to keep hitting the API. So what we do is I took one of the responses I got back from when we actually make this request. I took one of those responses and just created it as like a stub data and called it fixture. So anytime we want to reference this fixture, it would only load these 3 static jokes every time. And so how we implement that is, so we have a describe where we're stubbing the results. We reference these fixtures, which Cypress sort of under the hood, it knows, it just looks for the prefaces of these files. So jokes, you don't have to do jokes.json. It just knows whether it be a .text file or markdown or JSON, it can find those. And then we set it as an alias by doing .as, and this is going to be our jokes response. We're going to then visit this like we normally would. We want to do the same thing where we make sure that loader exists. We want to make sure it doesn't exist. But in this instance, anytime you want Cypress to sort of intercept your network calls, you create a Cypress server like this, and then you create custom routes. So you'll notice this is the same exact route that we actually use to make this call. So what here we want to say is anytime we try to get something from, it's going to listen and intercept network traffic of gets to this route, and instead of actually making the request, we just want to return this jokes response from this fixture. So on every single one of these tests, it's just going to return back this jokes data. And then we want to make sure in this instance, we want to make sure that the length is 3 and the image is 3, but we want to actually make sure that that those 3 specific instances of those jokes are the same for every single time. So this verifies that this is actually getting back stub data versus the random data jokes that you get every single time you run it. And then you could continue writing more and more tests. We could go on and on all day on some of the cool things that Cypress has to offer. But for the sake of brevity, let's finish up here. I only have a couple minutes. So finally, there's tons and tons more things we could get into, but the one real final thing that I wanted to hammer away at is the documentation with Cypress, in my opinion, is maybe some of the best documentation of really any framework or platform that I've ever used. It really just provides great ways to get started. It really does a great job of presenting the core concepts, giving you guides, talking about the specific tooling, different references, as well as it also gives you some recipes of like how you tackle certain behaviors. So if you're really new to Cypress, it really gives you out of the box some great documentation on how to write your first test, and so on and so forth. So I highly recommend, if you haven't visited their docs, it's a great place to start. And certainly if you have any questions, it's a great place to search. And if you have any, any other questions, their team is really great about responding on Twitter. So people on their team, if you have questions, if you mention Cypress or some of their team members, they're really great at getting back with you. It's a great place to start, as well as certainly myself. If you have any questions about Cypress or how using it could help your company or solve the problem you're trying to solve, or maybe save some time, or whatever your case may be. I know for me, I just finished working with on a project where the company organization I was working with had a very I don't want to say archaic, but they weren't big believers in automated testing. And so the one benefit of using Cypress is they did a lot of manual testing. So because Cypress literally opened up in a browser and they could see everything that was happening, it gave them the confidence that the right pieces were being tested. So it's a little bit about me. You can find me on Twitter. My handle is JordanPowell88. GitHub, Facebook. I have a blog at jordanpowell.online, and it was great being able to share a few things with you guys. There's so much with Cypress, such a great tool, but hopefully you've begun to maybe scratch the surface on just some of the great things that Cypress can do. Love to answer any other questions you guys might have, and thank you for your time.